about, who will tell us about the platform for experiments with typesetting algorithms. So, Didier, Verna, please.
I might increase the font size here. Make it smaller.
Maybe raise the microphone a bit closer.
Yeah.
And the other band.
Okay, thanks. Not that I'm going to use Emacs much, but just in case. Okay, hi everyone. So in this talk, I want to talk about a pet project of mine, which actually is quite ancient, as it dates back probably 9 years ago. I started working on it, but it's been more or less dormant since then. Back in the days, I actually wrote a couple of papers for the Tech Users Group conference, but it was really a side project, so I didn't have much time to work on it, and so I would like to start by giving you a disclaimer. I haven't touched the code since 2 years ago, so I more or less remember what's going on in the code that I wrote myself. But still, it's a project which I've used effectively to support a lecture on typesetting, for instance. So there's already a number of interesting things to show off. And at some point, I thought this is going to go into oblivion unless I do something about it. And typography is actually a fascinating topic, which I like very much. So I thought maybe writing a tool paper for ELS would be an incentive for me to start working back on the project in question. So this is what I'm going to talk about today. So digital typography in general and digital typesetting in particular is a quite fascinating domain because it practically every second combines a strong sense for aesthetics and the beauty of things, and also a number of very interesting technical challenges. There is, as you probably know, beauty in designing fonts, for instance. The way you shape characters is considerably focused on the beauty of things and on a sense of aesthetics. The way you can format paragraphs with justification algorithms, there is also a lot of subtlety and beauty in that. Then the way you combine paragraphs to put out pages and then whole complete documents can also be quite beautiful once you get the sense of it and once you become sensitive to the subtle details. And maybe to some extent the way it's done, which is also quite interesting. And at the same time, when I say it's full of technical challenges, what I mean by that is, for instance, if you take a stream of text with potentially n possible breakpoints to cut the paragraph into lines, you have 2 to the power of n possibilities for creating a paragraph, which is obviously huge. Okay. In such a situation, there are also many possibilities which don't make any sense. So, for instance, you would never typeset a paragraph by breaking after every word. It doesn't make any sense. So there's a lot of possibilities amongst those 2 to the power of n, which are completely absurd. So you can define a satisfiability criterion and try to filter out very quickly absurd solutions. But the problem if you do that, which is what tech does, for instance, to some extent, but the problem if you do that is actually that there will always be a case when a paragraph is impossible to typeset according to the criterion that you want to use. So you need to relax some constraints, and that is precisely the point at which the exponential complexity kicks you back in. Okay? So yes, it is difficult. There is a lot of challenges to be addressed. But if you are successful in doing that, there is a lot of beauty and a lot of satisfaction to get back from that. Just to illustrate this, I want to narrate an anecdote which dates back to 2012. This is a personal story which upset me quite a lot, and it's also a good. Oh, maybe I can remove my mask. Sorry. It's also interesting because this is the perfect illustration of what I'm trying to, the meaning I'm trying to convey here. So in 2012, I was writing a chapter for a book on DSLs. I will not disclose the name of the publisher for reasons that will become clear in a second. When I started to write the book, they provided a number of very strict rules for typesetting. They explained that I needed to use two-colon formatting, a precise geometry for pages, and all that stuff. So obviously, I used LaTeX to format to typeset my chapter. I sent the manuscript to the publisher, and they returned a message telling me, "This is all very nice. This is excellent, but could you please rewrite it in Word, because this is what we use to create the book." Okay, so it's not like I had a choice. So yes, I rewrote the whole thing in Word. I struggled for days with the bibliographic reference section and stuff like that. You can imagine the hell I was in. And so after a couple of weeks, they sent me back what's called the editor-proof version of the book. My chapter was the very first chapter in the book, and this is the very first paragraph of my chapter. So basically, this is like after just the table of contents, you fall on that. And if you look at this, so this is actually a piece of the first paragraph typeset in 2 colons. And if you look at that, well, I got angry like beyond words. There is probably at least 5 identifiable problems in that paragraph. It could be fun to know if you can spot some problems by yourselves. Yeah, can you spot some? Yes, interest. So let's do a Q&A. Let's do it interactively. Yes, what do you see is wrong here?
The
Bottom line is too compact. Yeah, for instance, yes. Personally, I tend to think that the first line is way too loose, actually, okay? So indeed, this first line is extremely loose, and it's probably looser than what the actual font definition allows. When you take a font, it usually comes with a number of aesthetic specifications. For instance, you have a dimension for the interword spacing, which usually amounts to 1/3 of an M, which is the width of the uppercase M letter. So this is probably much larger than that. And a font definition also comes with a measure of maximum stretchability for lines, and a minimum shrink and a maximum shrinkability as well. Okay, so the first line obviously goes beyond that. As you spotted by yourself, the last line does the exact opposite. It's way too compact. Okay, so it's really too. The words are almost unsplittable from the next one. What's wrong as well as you can probably spot here, I would have liked to get a ligature here between the F and the I, okay? Another problem that I see here is the variance between the stretchability and shrinkability of lines. This is related to what I said earlier, but if you have a line which is extremely loose and very close to this line, another line which is extremely compact, it is really disturbing for the eye, okay? Another problem which I'm going to illustrate later on in the talk is with the notion called kerning. It's practically obvious that there is no kerning done properly in this paragraph, and in particular, if you look at the final line, not only the words are too close to each other, but this is to the point that, to some extent, the interword spacing, for instance, here, is very close to the space between the O and the W. So at some point, it is even more disturbing in the sense that not only you have difficulties to split the words, but some words also have the tendency to look like 2 different words, okay? Though there is a huge amount of problems in this paragraph, okay? Obviously, tech would never issue something like this, okay? But at the time, at least, nowadays I don't know, but at the time, Word had no problem giving you something like that. So you can imagine how upset I was, given the fact that typesetting is something that I like. Just also to give you, when I was talking about exponential complexity, so 2 to the power of n possibilities for breaking a paragraph into lines. In that particular case, if you take just this piece of paragraph and you want to, reformulating the problem slightly differently, you want only 4 lines, then given all the hyphenation points and the interword places, you have, it's written here, it's 12,341 possibilities for making 4 lines out of this text. So this gives you a concrete idea of, how complicated this problem can be. Okay? So I think this is the perfect example of combining a sense of beauty, and you want to create something which makes sense and which is aesthetically pleasing, and at the same time the incredible technical challenge that you have behind that kind of problematic. Okay, so the general motivation for this project was, as I said, general interest for the application domain itself, but also there was a second motivation for this project, which is that I was giving a lecture on digital typesetting to my students at ETAP for quite some time. It originally started as basically a more or less technical lecture on how to use LaTeX properly. But at some time, I got bored by just teaching technical stuff, and yes, you use backslash, T table of contents to blah, blah, blah. I got bored doing that, and in some sense, even unconsciously, I gradually made the lecture evolve towards talking more about the beauty of nice typesetting and less about the technical details. But I realized at some point that the students were not necessarily completely sensitive to aesthetics, and many things they considered just nitpicking, and many times they thought I was just a complete maniac of some sort. So I was also looking for a way to get them the sense of aesthetics and the beauty. And I started with having pictures of stuff, kerning done wrong, kerning done nice. And that was not very striking as illustrations. So I also wanted to do something differently and make the whole thing more interactive. And this is the second motivation for the project. So I wanted to develop something which I could use in my lecture, which would be real-time and interactive. I wanted to play with parameters, play with typesetting options, features, and have the result be displayed in real time in a very striking way. And also I wanted to experiment myself with typesetting algorithms, for instance, paragraph justification and stuff like that, because for as much as the Knuth-Plas algorithm makes beautiful things, it also dates back to the 80s, and we know nowadays that there are a number of things that we can do differently or maybe better. Would it be simply because we don't have the same machines as before? And since the 80s, the computing power and the memory available has completely exploded. So these are the two motivations, the original motivations for the project. The problem is that you don't have any practical solution for doing that, hence my will to write something by myself. If you take WYSIWYG text editors right now, they are very interactive. They do stuff in real time. You type in the very same space that you see the typeset result. But those softwares, like I'm thinking LibreOffice, for instance, or stuff like that, they do not provide much customizability. They do not let you hack the typesetting algorithms themselves, for instance. If you go the tech direction on the other way around, tech is much more customizable in terms of the parameters that you can adjust, even based on differently for every single paragraph potentially. But tech is not so interactive. Even though you have some layers on top of it, most of the time you still follow the development, compilation, opening the DVI or the PDF, looking for the result, going back to Emacs, adjusting some parameters more or less blindly. So this is not satisfactory either. Okay? So this is why at the end I started developing my own platform for experimenting with typesetting algorithms and also for showing off nice and cool typesetting tricks to the students. And so I guess it's demo time. What time is it? Oh, yes, right. So I'm going to quickly show you the demo. So the software is called ETAP, and it's currently focused on paragraph justification, or paragraph formatting, shall I say. I'm sorry, I don't have a way to zoom the whole interface, so I hope that's still okay for you. This is small, right? Yeah, I apologize. This is the HDMI resolution. So very quickly, I'm going to start by describing the different areas in the GUI. So the area here is a simple text editor in which you can type stuff. There is a default paragraph here, and it's going to be automatically typeset down below. So I can, for instance, so even on my screen, I have a hard time reading what's written here in Olden. No, and efficient. It doesn't mean anything, but yes, I can zoom. Efficient times, whatever. So every time I type something here, it automatically retriggers the typesetting engine and updates the paragraph down below. I can obviously zoom the paragraph here, okay? This does not retrigger the typesetting engine. This is really a viewport zooming facility. So this is the basic thing. You have options at the top left corner for changing the disposition of the text. Not all dispositions actually make sense with every typesetting algorithm. Some do, some don't. But this one, for instance, is flush left. If you want to flush right, you can get that with the same typesetting algorithm. The algorithm displayed here is actually just a fixed one. This is the dumbest algorithm you can think of. It just puts words next to each other without any elastic space. So it's never able to justify properly, obviously. But this is the first one I implemented just in order to get everything working quickly. If you attempt to justify, what you get is essentially the same thing as flush left. You can also center the lines. Most of the time what happens, and this is not what happens in tech, for instance, but the flush right or flush left dispositions are actually computed by creating lines of the appropriate width and then flushing them one side or the other. That's basically all. You also have some, and that's where the interesting things start to appear. You have a number of features that you can switch on or off. So for instance, I can switch kerning on, and you will see the effect on the text. But you see that it's really subtle. And at that point, most of the time, the students go, yeah, you're just a maniac. We don't care about that, you know. But then I can do more, and this is where it gets interesting. I can do more because I can, for instance, do something like this, which I do. So this is a satisfied egg in French. But I can tell them, yes, kerning is important because, as you see, even though the difference is subtle, it can be explained because, for instance, if you look at the O and the E, the globs of ink are really close to each other, and the letters look like balloons. And so if they're too close to each other, it's disturbing. So with kerning, you want to separate them slightly more. And if I do this, it's visible in real time, and it's cool. And I get their attention doing so. There is the opposite thing is happening between the N and the T, if you can see that. It's different because the two letters have the same shape next to each other. So they would appear too separate from one another without kerning. So in the font definition, kerning makes those letters come closer to each other. And if at that point they're still not convinced that I'm not only a maniac, but this is really a cool thing, I can go that. And then most of the time they're convinced. They say, okay, yes, this is cool, this may be subtle, but okay, this is ugly. So we start from, you're just a maniac, to them actually realizing that without kerning, you get ugly stuff. It's striking like that. When I was using two pictures, it didn't work, basically, okay? Another cool feature that I can use to demonstrate the ins and the bells and whistles of typesetting, so I'm going to switch on kerning, is hyphenation. Hyphenation, as you know, is when you want to split a word because it's a best solution and you insert a hyphen somewhere. So as you can see here, the algorithm changed something. There is lime tree, which is which is split in two. But the case here is that the lime tree was already hyphenated because the hyphen is present in the text. So I can play with the paragraph width to avoid that and to insert new hyphens. But I'm going to switch algorithm. I'm going to use another algorithm here. And as you can see, this slider changes the width of the paragraph, and you can see it's typeset again in real time at every time I move the slider. And so I'm going to look for a point at which I get an interesting number. Here, for instance, you have two hyphenated lines, right? Okay. So if I switch hyphenation off, you see that the algorithm is going to look for another solution. Another nice feature is located here. I have a number of characters and clues which I can turn on and off. And so, for instance, for debugging purpose or experimentation, I can trigger hyphenation clues. And this will show me all the potential hyphenation points, which in turn become potential breakpoints for breaking lines. Okay, so this is actually quite cool because I can test algorithms. I could also test variations on the hyphenation algorithms. This one is the one from Tech, which is actually designed originally by a student of Don Knuth. And you can see, for instance, itself on the second line. At some point, it's going to, well, it's difficult to trigger hyphenation with a trackpad. No, I cannot get it to work here. Anyway, so you get the idea. What I can do also is, for instance, show the paragraph box. It helps. I can also show overfull and underfull box as in Tech. This algorithm is not going to, maybe yes, if I do that. No, not this, sorry, not this one. I need to use the best variant. No. Maybe the Barnet, yes, okay. So as you can see here, you get, as in Tech, overfull or underfull boxes, which are lines which you cannot in a satisfactory way format to the acceptable width. So it's going to show you whether the boxes are overfull or not, and so on and so on. Yes, another feature that I try to advertise to the student is ligatures. I can show you that. It's interesting. As you probably know, ligatures is when you have a number of characters, for instance, like that, and you want to combine them together because it's more beautiful. So most of the time, again, the students go like, yeah, we don't give a frack. I said frack, yeah. But with ligatures, and with the ability to automatically switch them on and off, it becomes much more interesting. You can also show them in real time that ligatures may be complicated because you can have ligatures with two letters like this. But if I add a new letter on top of the first one, before the first one, then you have a ligature for 3 characters, not only 2. So the ligaturing mechanism is actually slightly complex. It's not as simple as it may seem, okay? You can also do something like that and explain in real time, demonstrate in real time that when you have ligatures, there is a potential problem when you want to hyphenate a word. So there is an information that you need to store and keep along the processing of the text, because ligatures might be split back for hyphenation purpose. Okay, so this is what I'm trying to show you here. If you look at efficient, for instance, no, okay, I need to create. Yes, this is going to work probably. As you can No, sorry. Let's use this one. Whoop. Yes, as you can see, the ligature is here, but at some point, if the algorithm you have tries to hyphenate, then the ligature is gone. But you have the partial ligature down below. Okay, and it's cool to be able to show that in real time. Right? Okay. I'm almost out of time, so I just want to finish on the demo by advertising the almighty Knuth class algorithm, which I have, but as somebody rather well-known says, I'm not sure it's correct. I haven't tested it. I've not even proven it correct. It's obviously not the complete Knuth class algorithm because tech is full of all the bells and whistles that I don't have, math formulas and all that stuff. That is not the point of this platform. It really is for experimentation. But all the Knuth class algorithm adjustable parameters are here. I also have an implementation. Yes, okay. I also have, just finishing on this. Oh, nice. It's the first time it happened. Okay, anyway. So that's for the interface. I will just quickly end with a couple of words on some future work I intend to do on this. First of all, the internals, as I said, this is really the early development stages of the project, but it's already quite functional, as you saw. So what I want to do is stabilize the internals. The internals data structures are not completely satisfactory for me right now. I also want to instrumentize the code in the sense that keeping track of all the quantitative measurements, like those which tech does, for instance, in order to be able to experiment and have measures of satisfiability, of typesetting quality in a quantitative way, keep that around. The purpose of this is to experiment with extensions or variations on the Knuth class algorithm mostly, also to address some other typesetting problems which tech doesn't address, like reverse detection. And something which I intend to do, which is not going to be so complicated, is also to gather statistical measurements. What I would like to do, for instance, is run all the paragraph formatting algorithms that I have in some kind of batch processing script and gather all the quantitative measurements and compare them to get an idea of actually, is the Knuth class algorithm that better for the average paragraph? We know it's a good one for corner cases when there is complication, when the columns are narrow, for instance, but otherwise we don't really know. Also, being able to do performance comparison. If less clever algorithm is more efficient and is sufficient for you in terms of typesetting quality, there's no reason to do something extremely complicated. All that things. This is what I intend to do. I would like some help, maybe. Currently, there is only a LispWorks C API interface, which is not my primary development platform for Lisp, but I reckon that when I tried the GUI programming in Common Lisp for the first time, I couldn't make my way around Maclean on the Mac, for instance, and by no means, I mean that Maclean is not good. That is not my point. Maybe at the time it was lacking documentation, or it was not completely stable on the Mac. C API is properly documented. On the other hand, it's straightforward and extremely stable. So it's straightforward to open LispWorks and do something in C API. But if somebody wants to contribute other interfaces for this project, Maclean with anything else, and ECL, EQL, for instance, I will gladly merge your merge request on GitHub. Thank you very much.
Thanks, Didier. I guess given all our glitches, we can still have a couple of quick questions from chat.
Yes. There's a question here from the people online. Did you ever consider joining efforts with Mark Patiani from CL Typesetting?
So we've talked a number of times with Mark, and actually one of the two articles that I wrote for the Tech Users Group conference back in the days were based on the software that Mark wrote. Actually, I had written a layer on top of Mark's work. So yes, we haven't talked to each other for a while, but now that this project is going to to be revived to some extent. I'm sure we're going to exchange thoughts again.
And there's also a second longer question, which is, LaTeX is the standard in readable and pleasant typesetting, but it has also known drawbacks. For example, it can be quite hard to debug. Nowadays, there are some more or less standard readable and pleasant style sheets for HTML or markdown formatted text in the browser. Do you think such a study could be extended to this browser approach for a nice typesetting and make it even more beautiful from a LaTeX point of view?
Thank you very much. I hate you right now. I don't know how to answer that. I'm not too versed in browser stuff, technology, so I cannot really comment on that. I would, if I were to transform this work into an actual typesetting engine, I'd much rather stay within my favorite Lisp environment. And that was, in essence, what I was writing 9 years ago for the Tech Users Group papers. I'd much rather do it in Lisp with a programmatic layer embedded on top of, Knuth-like typesetting algorithms and stuff like that. The browser side, I can't comment, I'm sorry. Yes?
I have two questions which are not
yes,
meant.
yes.
I have two questions which are not meant to be answered.
Okay.
The first question is, where are the proceedings of the conference?
The previous ones?
The proceedings of this conference.
This conference.
It's not meant to be answered. And the second question is, what is your opinion about the future of the print industry?
Okay. First question, proceedings are going to be out. No, I don't need to answer, but I can try to provide an answer, yes.
You have to think about this when you do typesetting.
Yeah.
The fact that people don't print so much, but they do photos, like, turn around. This is the things that they print.
Yes, yes. Mm-hmm. Sure. Okay. What I can tell you from the point of view of digital typesetting perspectives, which is something that we discuss a lot also at the Tech Users Group, is the future of typesetting, not necessarily for printing, but in more general sense, is seems to be going towards the how shall I turn it? Self-adaptive documents. For instance, documents that you want to be able to read on a tablet or on a larger screen, or which you would want to print on pages. And those documents actually should reformat themselves to fit to the viewer's geometry. This is one of the topic of interests these days. Yeah. For the proceedings, most of the time we're issuing them right after the conference. I think Jim has a temporary.
One short side comment I have.
Yes.
On browsers. Can I talk? One side comment on browsers. In 1997, the first browser that was compliant to CSS 1.0 was written in Common Lisp by Gilbert Baumann, that some of you might know. Mm-hmm. And it includes the TeX algorithm for line breaking. And so,
oh, yeah. Okay.
So maybe we can join the work or revive it or something.
Okay. Cool.
Because I would think it's really, really nice to have a proper algorithm for line breaking in browsers
mm-hmm.
as well.
Mm-hmm. Sure. And it's just if I may quickly answer that, I'm convinced that nowadays we don't need the intricacies of the Knuth-Plus algorithm to make things right, yes. Because a lot of the complexity in the Knuth-Plus algorithm comes from the fact that Don was trying to optimize stuff for the machines he had during the 80s. So there is a lot of dynamic programming heuristics, which probably would not be that important, that critical for performance nowadays.